This is a video of a talk from Crater Remote Conf given to a live audience in February 2016. This video was made possible by sponsors like Modulus.io, okgrow.com, and SpaceDojo.com. If you would like to find out more information about upcoming conferences, be sure to go to conf.crater.io and put your email in the form that pops up in the lower left corner. Enjoy the video. All right, welcome back. So if you didn't catch it, there was a slight scheduling conflict. So we're supposed to have Sam Hatoum speak next about delivering high quality features faster. But he had another meeting that he had to do that kind of popped up at the last minute. So we're going to see if we can actually schedule that for maybe next week and do kind of like an impromptu extra little talk. So bonus talk. And instead, I saved myself as a backup. So I got a talk ready today on building your own Galaxy hosting setup. So let me see if I can share my screen. Share. Here we go. Present. You know what? Let me exit full screen. Move this over so I can kind of keep an eye on it. There we go. All right, can everybody see my screen okay? Just let me know in the comments. So, all right, looks like we're good. Building your own hosting setup for Meteor.js. We're going to be talking about like the implications of hosting Meteor and the different tools that you can use to make it a little more performant. This isn't so much like some kind of like fancy UI to auto scale your setup or anything like that. So, but we're gonna kind of dive into the technical guts of how I have things set up. And in case you don't know who I am, these are the different places you can find me. So I've been working on, I still haven't finished it yet, but transitioning from Meteor Club to Space Dojo. And obviously I renamed the Meteor podcast to the Crater podcast because we talk about news on Crater. So yeah, that's that. And then we'll actually be talking about how Crater is set up for hosting. So I think, you know, this one cracks me up. Someone said this in the Slack chat room, and I was like, oh, that's perfect. And I found this, and I was like, you know what? It takes a real cast of characters to host any app, right? And so, like, Meteor is just one small piece of that, in my opinion. And you know, there's other pieces you have to use, and so we'll get into like CloudFront and pre-render and Mongo and a bunch of other things. And so, I thought the picture was kind of fitting. So this is how Crater is set up right now, and this I'll be putting all this on a blog post as well. So you'll be able to see hopefully a higher res version of a lot of this stuff as well. But right now, you know, I did a series. I did an article where I kind of compared Modulus and Heroku and DigitalOcean, and kind of talked about the differences between them all. And in doing that, like I actually ran Crater for a little while on each one. And so it ended up on DigitalOcean. And oddly enough, like it's just stayed there. And Galaxy sounded super interesting to me, but I didn't get an invite for quite a while. And then when I finally did get an invite, my concern was that with the 512 megabyte containers and being limited to 5, that wasn't going to be enough to host Crater in its current state. And so what I did instead is just started to slowly expand the setup at DigitalOcean. And so you can see when you type it in at the top there, the laptop, Crater.io, it's going to hit an Nginx load balancer, and then it's going to take a look at a bunch of different things. We'll get into all those different things. And if you're, a spider or some kind of bot trying to get some information, we'll shoot you over to pre-render, which is going to grab, and it's a hosted version of pre-render. It's not like the paid version of prerender.io. So their app is open source and you can install it yourself if you want. And so I wanted something that lived a little closer, might be a little more performant. And so that's a 2 gigabyte server there in DigitalOcean, or 1 gigabyte, I guess. And then if you're a regular user, you'll hit the Meteor servers, and we've got the load balancer will just kind of like evenly spread out the connected users, and it does a pretty good job. We'll see some Kadira stats in a little bit, and you can kind of see, and we'll get into how that is handled as well. But then, when you request the Meteor app, so if you haven't seen this before, you can do view page source on your Meteor app, and you'll see you get like just a tiny bit of HTML. There's some JSON at the top, and then some references to some files, JavaScript and CSS. And those files are the compiled like versions of your Meteor app and the CSS that goes with it. And so we'll get into it as well, but I use CloudFront for that. And it references, like there's a nifty little trick that you can use, and it'll reference CloudFront, and those files will get out there for you, and you can serve those up quickly as well, which is pretty awesome. And then I use Compose on the back end, and I've got the oplog set up. It's I think it's super important to use oplog when you're hosting a Meteor app and you care about production performance. I actually had a code review last week where I actually took a look at the code. It was great. It was very clean. It looked amazing. They did a great job. They needed to add some indexing to their database, but their real problem was they didn't have oplog turned on, and like they were dying with like 10 to 12 people connected. And so oplog, super important if you plan to have any kind of bigger user base. And we can probably get into that in the questions too if you want to understand that more. So does Meteor scale? I would say, I wrote an article about this last week. I think I put it out. I think that for most of the people here, like this talk will seem interesting to you, but likely won't be relevant because you're not really going to have the problem of needing to scale a Meteor app. So I'm going to tell you about all this, but in reality, you're probably better off not hosting your own Meteor app. Just use a platform as a service. It's going to be the TLDR of this. Yeah, I don't know. I think to me, the hardest part of getting any app up to the point where you even care about scaling it is really like, that's a huge marketing effort. So that's really something that takes a lot of work. And for me, like it's been a lifetime learning skill, figuring out how to like convince people they should take a look at your application or something. And that was, if I look back, I wrote a post a couple of years back. I was doing a Ruby or a Rails startup that worked with Twitter, and we spent so much time like engineering it, making sure it could scale and doing all this stuff. And at the end of the day, like we shut it down because like we got 10 people to pay us, and it was such a like big waste of time. And I look back on it, like we spent so much time on using Chef and trying to scale as best we could. And in reality, we didn't need to do any of that kind of work. So that's kind of what I'm getting at here. Come on. Oops, too far. Machine is laggy. There we go. Okay. Too far again. Come on. All right. I don't know what's up with my machine. Still too far. Must be a big image or something. So the slide here, there we go. So load balancing with Nginx. This was interesting, right? So for me, I used to do a podcast called webpulp.tv, and I talked to people about how they would scale their applications, and I would try to get like insight into how all that worked. Of course, my dog's going nuts now. And you know, we talked about all these really interesting tools like Varnish and HA Proxy and all these interesting things. And so, you know, I was sort of familiar with some of it, working on projects like Words with Friends, but I actually hadn't used Nginx to do the load balancing. And one of the reasons why I had never done that is because HA Proxy has this thing called out-of-band health checks. And the idea is, like, if you set up Nginx and you just use the normal kind of proxy setup, you know, flip forward a slide here. If you use the normal proxy setup here, right, like upstream, and I tell it to use IP hash, and I give it 2 servers to kind of rotate between, what happens is your client's going to connect, and without the out-of-band health check, they're going to do an in-band health check, which means that you have to wait for a failure to happen to someone before a server is taken out of rotation. And then you also have to configure that. So by default, it'll still keep sending people to that same server. And so there's some config you can do to make that work a little better, but you have to set out like a timeout and a number of failures before it gets pulled out of the pool. So instead, what you can do is this out-of-band health check. So we're not relying on the client to check the health of the server, but instead you can see here every 3 seconds, this check call, this is a module that I installed in Nginx, actually goes and does a health check and then reports back. And if a server goes down, it'll pull it out of the rotation pool. And there, you know, we're not dealing with hopefully anyone getting like a 502 returned to them when they're pulling up a page. And so out of band health check, you can get it by default in Nginx Plus, which is pretty expensive, or you can install the module that was on the previous screen. There you go. Nginx upstream check module, and it's really easy to do. I'll have all the kind of how-to links in the article, but you just kind of compile it, and then you just add this one-line check, and it does everything that it needs to do, and it's great. And so the rise and fall is just like how many times it has to be down before it's pulled out of the pool, and then the rise is like how many checks does it have to be up for before it's put back in the pool. And so, you know, if you want to be like super strict, you could like ratchet these numbers down and probably catch a down server much faster. But this seems to work for Crater anyway. All right. So the other thing when it comes to setting up Nginx or any kind of proxy in front of Meteor, you have to have sticky sessions. And so, you know, I hear a lot of people, they're like, well, what's a sticky session and why does that matter? And so a sticky session, if you think about how Meteor works in regards to querying data and returning that data to someone through DDP, it keeps track of that data that it cares about in memory on the server. And so if you connect, let's say you connect to server A, and you get some data, it's sent down to you, and then all of a sudden, like your connection, something between you and server A drops, and you make a new DDP connection, and it ends up on server B. All of a sudden, server B is going to see requests for that data. You've already got the data, but you just requested it again. So it's going to go fetch it. It's going to resend it to you. And now you've got 2 servers that think that they care about that data. And at some point, hopefully, server A drops, figures out that you're not connected anymore and stops caring that you had that data. But we've just put essentially double the load on the system. So we want to make sure if someone drops their connection and they reconnect, they're going to come back to the same server. And so that's what sticky sessions are. And in HA proxy land, you can set a cookie and read that cookie as they come back in through the proxy and then send them to the same server again. With Nginx, you can do things like IP hash. So basically, when you're connecting, look at the IP, run a hash algorithm against it, and it's going to choose, server A or server B. But since your IP doesn't really change, you should still end up going back to server A if you had to reconnect for some reason. So that's why sticky sessions are super, super important. And we can kind of see, like, as we get to some of the Kadira graphs, the other reason, you can kind of see the effects of like increased load from, a bunch of people connecting. All right, what's up next? Come on, machine. Jeez. Too far again. All right. Here we go. So this is my little rant. So for those that haven't heard of pre-render, Carl talked about it a little bit in his talk. He mentioned it slightly, or spiderable, or why you'd want to use some kind of service that's basically going to take your JavaScript, turn it into HTML, and then deliver it back to a bot, right? And so Google, they made a change back in October, maybe, that they're going to start consuming JavaScript more and more, and they're trying to do a better job at that. But in reality, like, they still will come through and consume. And you could see this is an actual output of the process tree on the one of the Crater servers as it was getting slurped up by Google. And so the thing is, it would detect Google coming in, and deep in the guts, the way Spiderable works is it uses Connect inside of Meteor, and so when Connect detects that you're one of a certain type of agent, it will, instead of rendering and serving the normal page, it will fire up a Phantom.js instance, hit the server, get the HTML or get the JavaScript, render out the HTML, and then return that to the bot. But the problem is it's like a super naive code here. You can see like Google sent a ton of bots to the system and basically essentially DDoSed the site, right? It's distributed denial of service attack by Google. And there's no good solution. I know that you can go and look and see there's quite a few pull requests for trying to fix some of this stuff, but none of it's been really kind of maintained or taken care of in regards to Meteor. So instead, what's better right now is to use pre-render, which is kind of the same thing. You detect that a bot came in, and someone pointed out in the comments, Facebook and Twitter and Slack and all those kinds of places, when you share a link, they also send the bot to try to scrape for information. And pre-render has a server that's running that essentially does the same thing as Phantom, but they put a lot more process around it, a lot more thought into how it works. And therefore, they've got, if you use their paid service, they've got a bunch of servers sitting there waiting to answer and like pull down the information, and then they cache it, in their system. And we kind of do a similar thing with Crater. So that's why you want to use pre-render. And I just used the Docker version of pre-render. I didn't have to do really anything special to it. I just I use Docker to like create a machine and then deploy this Docker image straight to it. The only thing that I did is I did set up, so I've got a 1 gig server, but I've got 2 Docker instances running pre-render, and they're both limited to about 400 megabytes. So like as they start to leak a little bit of memory, they just restart themselves. And with having two of them available, it's really not that big of a deal. And I've got Nginx in front of that as well to kind of handle detecting who's up and who's down. Yeah, so caching and dealing with the pre-render upstream. So I got some of this stuff from Michael Shillman, and he's a great resource. Like, I just want to say thank you to him because, you know, I was talking about my struggles in the Space Dojo chat room, and he mentioned that he was using pre-render and shared his Nginx config with me, and like I've just kept building off of that. And so right now I'm just using, you can see like we just set up the pre-render server, and then I also set up this cache path, which is just file caching. And I'm telling it, you know, you can save up to a gig of data and keep it for up to 120 minutes before it's considered inactive, and we'll replace it. And so the Nginx config here starts to get a little more complicated. And this, again, this is the load balancer. So you can see like up top, I set up the SSL stuff, which is also important. And then down below where the arrows are, excuse me, you can see we're detecting what's the user agent. And I kid you not, this is like, that user agent list is probably double what's in Spiderable right now. Spiderable is not super great. And then we're also detecting like if they have the escaped fragment bit on there, then we'll mark it for pre-render. And then you can see down in the pre-render, we tell it we don't want to skip the cache. And then we pass that query straight onto the pre-render server. And so this allows us to kind of detect and pass to a different area. Yeah. So now we'll talk about the other side when not to pre-render. And so basically, we're going to detect if the agent is pre-render. We don't want to send them to pre-render. That would be an infinite loop. Or if they're asking for any particular files, and Pete Corey mentions in the comments that, you know, you want to use a CDN or something. I actually think this is maybe the special sauce that you were having a problem with here, Pete. You know, you want to detect these files, and we don't want to send those files onto pre-render. We want to serve those files up instead. So that's kind of important as well. And then, you know, if we know that it's a real Meteor client instead of a pre-render client, then we'll skip the caching part and we'll send them on to the regular Meteor servers. And then anything we didn't catch, by default, you'll see down at the very bottom, the bottom arrow down here, the proxy pass, they'll head on to Crater as well. You know what I didn't do here is we should probably, we should set the default skip cache to 1 as well to make sure we don't cache any regular client. Huh. Yeah, interesting. I should fix that. Yeah, and so the skip cache part that I'm talking about here, this is the other kind of neat thing, right? This is what works with that previous caching that we had set up, and we said keep it for 120 minutes, and you can keep up to a gig of data there. So what happens is we send a request off, right? And if it's a pre-render request, we're gonna say yes, we do want to cache that. Don't bypass the cache, and what'll happen is Nginx keeps a local copy of that. And the next time someone comes in, so let's say we're getting a lot of Facebook or Slack requests or something, if it's popular, then we'll have that cached already in there, and it'll serve it up in, you know, milliseconds instead of having to go through the entire render cycle. So pre-render is important, and I think caching is also important. All right, so CDN is also important, right? And so that was that cloud that was sitting there in the initial diagram I showed you. And I've got a blog post on this. I think it's important to use a CDN for a number of reasons, and I mentioned it towards the end of the blog post. But basically, when a client connects to your site, they're only going to make two connections per domain, right? And so when you connect to Crater, if you have more than two files that are coming from Crater.io, and this includes things like WebSockets and all that kind of stuff, you're only going to make those two connections, and it's not going to fetch the next thing that it needs from that domain until one of the previous connections finishes. And so if you think about it, like a lot of the images for like user avatars come from Twitter as well. So if we've got 10 avatars and 8 of them are from Twitter, we're only going to get 2 at a time until we get through all 8. So that can slow down a little bit of the rendering on the page. And, honestly, like in doing research for the blog post that I've got, I couldn't find any recent talk about how this had changed. And as far as I can tell, most browsers are still set at 2. Some of them have bumped up to 4 connections per domain, but there really is like this limit, and I don't know if there's a specific reason for it, but you need to be aware of that when you're thinking about how you're going to deliver it. And so moving to a CDN gives you an additional 2 kind of wow, totally open. Turn off notifications. So turning that on is important. Anyway, yeah, CloudFront, setting it up, like using it within the Meteor application is actually super easy, underdocumented, but super easy. Turned out all you need to do is set this bundle.js CSS prefix, which I use a Meteor setting for. And I just put this somewhere in my server-side code, and when it's booting up, it's going to set that. And so if you go look, if you do a view source, you'll see I get this weird CloudFront URL in front of the JavaScript and CSS files. And is CloudFront similar to Akami? Yeah. They're both CDNs. They're both content delivery networks. So it's this idea that a file is put into the network, and then you have maybe 40 servers spread across the globe, and they use there's different techniques, but you can use like DNS. So I can see your DNS server is maybe coming out of New York City, and therefore I'll serve the file to you from the New York City server. Or if you're from India, then I can serve you the file from a server closer to India. So that's kind of the idea behind a CDN. And so, with Meteor, like this is all you have to do, and it's going to put that prefix in place for you. And so because we've set all these custom origins up in the previous slide, these slides are maybe out of order. We're going to reference a file that's not there yet in CloudFront, and they're going to know, hey, I should go back to Crater and grab that file directly. And so it's going to ask for the Crater version of the file, and it's going to get it, and then it's going to cache it in its content delivery network and serve that going forward. And so once the file gets out there, then we don't have to worry about like serving that up quickly to other people. Like they're going to distribute amongst their network. And the great thing is, like Meteor already has, as part of this, their bundling process, they already have a cache busting system built in. So if you look at like your JavaScript or your CSS file name, it's going to be this weird hash of letters and numbers. And in reality, they're running similar. They're just running an algorithm like an MD5 hash to look at the file and determine like, is it the same? If it's the same, you should get the same file name. If it's different, right, because we've deployed a new version and some code's changed, it's going to change that string. And now we're going to be requesting a different file from CloudFront. And so that's how they kind of handle that cache busting, which is smart. That's how, from my days in Rails, that's how things work there too. Love that. All right. So we talked about pre-render, we talked about CloudFront, now the Meteor servers. And so for me, like I just use plain old MUP. You could use MUP-X. For some that aren't familiar with that, that's like the next generation Docker version. I actually have some apps on MUP and some on MUP-X. But basically, it'll just deploy a Dockerized version for you. And I think it uses Nginx for doing the SSL stuff. MUP, Crater was already on MUP, so I really haven't bothered to migrate it. And I'm not sure that I would see any major reason to. I actually configure all my own SSL stuff, so I was fine with that. But in reality, so when you're adding a second server to MUP, all you have to do is pass, the server's key in your mup.json, just pass it an array of servers, and it's going to know to connect to those, and it's going to do it, one at a time and go through and deploy. And I think at first I was like, is this not good? I don't know. Maybe I want to, like, Capistrano could actually deploy. If you're not familiar with that, that's a Rails deploy tool. Could deploy to like multiple servers all at once. But the more I think about it, the better we are, because we get this zero downtime kind of deployment, which I'll show you a screen of in a second. But you can see here, like when I type deploy, it's going to bundle up and deploy to the first server, and then it's going to bundle up and deploy to the second server, and it happens in succession. So, the first server, as it's deploying, is going to go down, get the deployment done, come back up, and then the second server is going to start going through its cycle. And so your deploy is maybe a little bit slower as a developer, but it's better in the end because we get this zero downtime deploy, and you can kind of see here in the total sessions, right? Like we're humming along. You can see these lines are almost exactly the same for the two. Probably like a couple people different. This is just people connecting and disconnecting. But then I started to deploy here. I didn't actually have anything to deploy, but I wanted this nice graph so you guys could see it. You can see like the first server goes down, and it's like, our connected sessions drop way down here, and this one spikes up all of a sudden, and then this one drops, and then they start to even out. I guess this one, the blue line, probably deployed first, and then the maroon line, and then they start to even out again, right? And so that's the sticky session that we were talking about before. And you can see, this is the piece I was talking about earlier. The pub sub response just drastically like shoots way up, like off the charts. When I first looked at this chart, like this was definitely a high point, but then like this stuff like was probably, you can see it's up in the 40,000 milliseconds. And basically what's happening is we're dumping off all the users from one server to another, and that means that we're starting to do a bunch of queries against the same tables, or collections. So we're asking for all the user information and trying to verify that they're logged in, and then we're looking at their connected client version and trying to figure that out. And then any publications that they have on top of that are getting re-grabbed. And so we just have this huge influx of people coming in, and there's just like a lot that it has to get through, and it has to do it as a single server. And so I think that's why, like, if you think about how the node event loop works, it's only able to, respond, like there's blocking pieces of the process. And so it's got to finish a piece before it can respond to another piece. And an event loop can be an efficient way to do that. But when I said tables. When we do that, like when we have a bunch of people connecting in all at once, we just have a flood of people hitting the server and really hitting the database and trying to get a bunch of data out of the same table too. So like everything just kind of slows way, way down. So just interesting. And then I think the other super important piece when you're deploying, like I mentioned this earlier, you really want to use that oplog support. And so I use Compose, and as Galaxy also does not offer any kind of database option, I just, I actually found that when I wrote the original article about the different like Heroku and um, Modulus and DigitalOcean, I moved all the data to Compose and turned on Oplog, and that actually made it easier to move from one service to the other. I didn't have to move any data. I just supplied them with the same connection string, and it would pull the site up. So as long as I had the same version of code deployed, you can actually run it anywhere and connect in. The one thing that I had done initially, though, and I redid this as part of this effort back in November. The Crater database was hosted in AWS, but the data or the servers were deployed into DigitalOcean New York City 3. Or actually, they were New York City 1. So Compose, I don't know if they still do this. I went and looked and couldn't find the option. Compose offered DigitalOcean deployments, and you could say New York City 3. And so I went ahead and moved all my servers over to New York City 3, and then set up this this database in New York City 3 as well. And so now, yeah, they say they do on their site, but I went in and looked, and like I couldn't find, like I tried to do a new deployment, and they offered Amazon Amazon zones, and they offered soft layer. So I don't know, maybe something's up with DigitalOcean right now. So yeah, I think it's super important. And so like moving that database closer, I think reduced some latency, and then turning on that oplog access is super super important, because if you don't turn that on, for every user that connects, you're going to be running basically a loop every 10 seconds or so and saying, is this data updated? And that can become super expensive, and it'll spike your CPU up. I think Devin's in here watching. He can probably attest to this. Like, they didn't have oplog turned on in their application, and they were like drowning under 10 or 15 connected users, and they turned on oplog, and CPU usage shot way down, started getting much better performance. So this is like the number one low hanging fruit, easiest thing you can do to scale Meteor is make sure you're using Mongo with oplog turned on. All right. So let's do some questions. Get out of full screen. It's kind of hard to run my own session here. All right. There we go. So Elijah asks, is it easy to turn on oplog if hosting on Modulus? No, actually right now it's not easy to turn on oplog if you're hosting on Modulus. I would not actually recommend hosting your database with Modulus. I actually think that it's a pretty not so awesome option. They basically, you're on a huge shared database server, which can be problematic. And then they also don't give you oplog access. So I think you can like get a custom install, but at that price, I think it's upwards of $200 a month. At that price, you could probably just as easily go get a better performance setup over at Compose or MongoLab or somewhere like that. But both MongoLab and Compose offer really good options. Any of their paid plans basically give you the oplog access. So I would highly, highly recommend that. Oh, maybe I misunderstood the question. So I was reading the comments. So really, I think if you're hosting the database at Modulus, it's not easy to turn on uplog. But if you're hosting the Meteor app there and you have an uplog enabled database, all you have to do is give it a Meteor uplog URL and environment variables, and it'll start using it. Yeah. So maybe hopefully that clarifies it for some people. So Elijah asked, what are some differences between Modulus and Galaxy? So Modulus right now doesn't really use Docker, and their hosting setup is different, maybe a little less standardized with today's setup. So the thing there is they're using Docker to compile your app into a slug, and then they use that slug to like deploy to their servers, and that's a little bit different. It's probably closer to Heroku than it is to Galaxy. That's similar to how Heroku works, and so if you look at their build packs, it's very, very similar. They just don't really. Like, I don't think there's a way to tell Modulus, like, here's my custom build pack. I could be wrong. Maybe they've changed that. But I know that they were looking to maybe move to a Docker setup at some point. But in reality, Galaxy, that's a good question, Robert. You should put it down in the questions. Galaxy is using Docker. And I think that's a little more like current state-of-the-art thinking. It's deploying containers for you, and you can, one of the advantages of containers is that you can kind of decide that a container is going to be this size, right? And so I talked about it a little bit in regards to pre-render. I can say like, hey, don't let these guys get over 400 megabytes, and it'll actually just restart those for me, whenever it needs to. So Docker is kind of handling some of that infrastructure. And so I think that's maybe the major difference. And Galaxy's maybe prettier. Like Dom's done a better job on the UI. But I think Galaxy's working on a new dashboard, or not Galaxy, but Modulus is working on a new dashboard. All right. So Isaac asked, how hard is it to set up Let's Encrypt with Meteor using my setup? Probably slightly harder than it should be because I'm using Nginx. Their Nginx support is experimental. I actually looked at it the other day because I was wanting to set up a new SSL cert for one of the podcast sites that I don't have it on yet. And I just kind of, after about 15 minutes of reading, just decided to punt on it for a little while until I had more time to investigate how it would work with an Nginx app. But the idea is like, if you've ever done SSL before, the idea of it, Let's Encrypt is you don't have to do all this weird like emailing back and forth and proving you own the domain and all that kind of stuff. Instead, they just they come in and like put a little response on your web server, and then they're able to check that that's the web server you say it is, and they're able to prove everything that way, and then issue an SSL cert. So I actually think it's a great way to do it, and when I figure out how to get it working with Nginx, I look forward to using it more for sure. Alrighty. So Ryan asked, any particular reason for using DigitalOcean for your Meteor servers rather than EC2 on AWS? So for me, yes, there is a particular reason. One, DigitalOcean just generally, like a while back I saw like scoring of AWS versus DigitalOcean, and they tend to win performance-wise. They do a little bit better. I don't know. I like underdogs. Maybe that's another reason. I also have some credit there. So I mentioned I wrote a blog post about like 8 ways to save money for your startup, and part of that was hosting your own setup. And I I got a lot of people that clicked on a referral link from that post, and I've got like $2,000 in potential credit there. So as people are flipping over, I'm getting like $25 a month here and there. So it's kind of helping offset the cost of hosting. But I'm pretty sure like if you look hard enough, you can find like a bunch of AWS credits as well for startups. So, yeah, hopefully that answers that. You're deploying as root user. No, I was logged in as root user to take some of those screenshots, but I don't deploy as root user. Meteor up actually creates like a Meteor up user that it runs all the code as. So to answer your question, root, Will, no, I'm not deploying as root. Excuse me, a lot of talking. What are some of the ways to stress test a Meteor site? Any way for us to find out how many concurrent users can handle in a given setting so as to tweak it further to make it more performant? So the first thing I would say is like get Kadira installed. You saw the screenshot. You can actually dive pretty deep into what's going on in your Meteor app with Kadira. So I'd highly recommend getting that set up. And then, there's a whole gamut of stress testing that you can do. You can do something as easy as Apache benchmark, right? So you can type AB and hit a URL and just throw a lot of traffic at a site. That's maybe not the best way. That's pretty naive, I guess. There are some other tools. I'm pretty sure Aeronota has one. I don't have it right in front of me right now, but there's like a load testing tool from Kadira. Let's see. Yeah, I don't see it right now. Maybe someone's got better Google skills than me. Meteor down. That's it. I found it. All right. Yeah, so I would recommend taking a look at Meteor down. There was another one called Meteor load test, which was actually using, I think, Maven and some Java stuff to load test. But Meteor down, I think you can actually make subscription calls and all kinds of interesting things. So you can test that side of things. And again, like if you're using a CDN, you're gonna like you're delivering a little bit of HTML. You're going to deliver your CSS and JavaScript from the CDN. So the stuff you care about for scaling purposes is going to be like the DDP stuff. So Meteor down is a good option there. So the next question from Gavin as well is if we were to use DDP over normal Meteor architecture for the same application, would it support a greater number of concurrent connections for the same hosting setup? I'm not sure I follow the question. If we were to use DDP over normal. Yeah, I don't know. Maybe you can clarify that for me, Gavin. I'd be happy to answer it. Maybe re-ask that in a different way. So Isaac asked, have you tried out the beta of Tutum? If so, what did you think about it compared to the other options out there? Well, obviously, like Docker, like Tutum, right? They bought them. I think that it's an interesting option, and I think that we'll hear a lot more about Tutum tomorrow when Jeremy talks about using Docker to deploy like an auto scaling setup. I think that's going to be a great talk. And I looked at it a little bit, but I just didn't want to get that heavy into it. I probably poured maybe 25 hours into this project so far, and it was more of I like this stuff, so I was playing with it on the side. But I didn't want to go full on like DevOps on everything. Hopefully that is helpful. There There's another question. Yes. So in the comments, yeah. But at the same time, like so Rolf just said, so my Galaxy is 25 hours and MDG is like 25,000. True. But the reason you go with Modulus or Heroku or Galaxy is because you deploying it is more like an hour tops, not 25 hours. So while I find that time valuable because I'm going to blog about it and hopefully it helps other people with hosting, I'm not sure that that's the best use of your like business time, I guess. Like if I put on my business cat tie and stuff, like I'd probably tell myself not to do that again. The other question Ryan had in the comments was, what about auto scaling your instances? Do you do it manually in DigitalOcean? I actually do. And so the easy way to do this, like the hackery way to do this, is to take an image of one of your app servers and then just deploy that image to a new server. And so then, once deployed, I just take that internal DigitalOcean IP and pop it into my load balancer. And then, maybe it's a 5-minute process to do by hand. So not as great at auto scaling as say something like Galaxy or Heroku. But it's definitely not super hard either. Pretty easy to get going. Avaldis asks, can we scale Meteor apps easily on Heroku? I would say yes, absolutely. They've got their Dino system, very similar to servos over on Modulus or containers over on Galaxy. Basically, they're just processes running, and they offer sticky session support now. They added it maybe 2 years ago, year and a half ago. Which is the key, right? That's the piece you need in place there. And so you can just tell them like, yes, ratchet up to 2 dynos, and your configs should come along with it, and it'll start a second copy, and all of a sudden you're load balancing. So yeah, you could absolutely easily do it on Heroku. And I think I've talked to Paul Dowman at OK Grow. They use Heroku for a lot of their customers, because they have a better model for sharing permissions to applications. And the thing I miss is like pushing a Git repo. So I'd love to get Crater set up so that I do like a Git push somewhere, and then it like starts the deploy process, because it's not always readily apparent. Like I like having the control of like checking in some code and then knowing that's the code that's getting deployed, versus with like MUP, you're in your local copy and it's going to tarball your local copy. And so if I have a config that's off in my local copy, like that's just, I don't know, that's not good. Bad things happen. All right. Well, let's take a short break. We've got about 9 minutes left. And then we'll come back at 4 o'clock, and we will listen to Ian talk about how you can use DDP to build APIs. Thanks, guys. This video has been a Space Dojo production. You can click the Learn More button to find out more about us at spacedojo.com. Or you can click the subscribe button to get notified about new videos we put out each week. Thanks for watching.